Okay, now we're in business. So -5 to 4, -5 is included because of the less than or equal to, 4 is not because it's strictly less than. And then again, it's just when X is in this piece, you do this. When it's in this piece, you do that. When it's in this piece, you do that, right? So if X is between -5 and -3, it's just gonna look like Y equals 5. What does Y equals 5 look like? Y equals 5. Horizontal line, 5, right? Okay, so horizontal line, but only for X between -5 and -3. Oh, that's this. A horizontal line, but just a little chunk of one, right? You cut the ends off. You keep one endpoint because it'll be or equal to, the other one you don't. Okay, then Y equals X plus 2. Okay, Y equals X plus 2 is a line like that. Again, we chop the ends off at -3 and 1 and just keep that little piece, right? So you get this, -2x plus 5. Again, it's just a line between 1 and 4, like that. These happen to meet up at the same point. That's cool, interesting, I guess. Doesn't really matter. Doesn't have to happen, right? Like these don't meet up at the same point. It's still a function though, because we looked at that one yesterday. One of those points is like actually there, right? Like solid. The other is open, so it doesn't actually get to that point right here. Okay, I'm not going to ask you to do a whole lot with this. Basically, just be able to sort of interpret the notation. So if I want to find f of -4 and I have this to work with, what do we do? Plug -4 in for x. Okay, the question is where though? If x is -4, which of those three things should I use to evaluate or plug in? First one, why? That's the one and only place that -4 would fit, right? That would make that statement, that inequality true, right? If I try putting -4 in here, -4 is between -5 and -3. It's not between -3 and 1. It's not between 1 and 4. These two things would not be true, so I don't use them, right? Okay. So I would plug -4 in, I would just plug it into that top piece. So for purposes of, this evaluation, the only one I'm interested in is sort of that top line of the thing, right? Okay, so what about plugging in or evaluating f of 0? Actually, y'all take a minute. Think about the other two. F of 0, f of 2. You already know the answers from up above. Maybe 2 might be different, but plug those things in, decide which piece, and then do it, and see what you get. All right, f of 0. So which of those three pieces or those three equations do we use to find f of 0? Second one, right? Because 0 is in here. So f of 0 is 0 plus 2. So it's 2. And what about f of 2? The last one, because 2 is between 1 and 4. So it's not any different really than any other time we've done function evaluations, right? We just have kind of one extra step at the front end to decide like, okay, I'm gonna plug into this function, but which piece do I actually plug in to? Like which rule do we actually follow? And again, that's based on where you are, right? If the X value is 2, the only one of these statements that would be true is this last one I use, right? Okay. Again, to use like a real world example, like I don't care what the tax rate is if your income is $500,000 a year, because I don't make $500,000 a year, right? So evaluating F of 2, I don't care what happens here or here because those don't apply to me. That's not me. That's not my life, right? If X is 2, I'm right here. So, okay, I use this then to figure out what happens, right? We okay with that? All right, that's it. That's all there is to it, right? It's just decide which one to use and then do that. Okay. And then the homework for this should be, kind of similar. Just, once you kind of get that one idea, it shouldn't really be any real huge deal. Yeah. Okay. So sort of our last new topic for test. I've already lost count. Our last topic for test stuff is how we work with circles. It's kind of out of left field, but it doesn't really fit in anyway. So. Okay. So circles. So first of all, one thing kind of right off the bat about circles is that they are a relation still, because if I think about putting a circle in the plane, it's still a bunch of points, right? A bunch of XY pairs all together. They are definitely not going to keep that like function relationship though, right? Why not? Doesn't pass a vertical line test, right? Doesn't pass a vertical line test. Wouldn't pass a horizontal line test either. So not a function. Certainly not one-to-one either. So that part's kind of, we're kind of setting that aside for the moment, and again dealing with circle. You know what a circle is. Let's kind of refresh ourselves on a little bit of terminology stuff. Or maybe even just the definition of a circle. Like, how would you describe what a circle is? Or how would you draw a circle well?
Symmetrical shape, geometric.
Okay.
Shape that doesn't have any corners.
Okay. Doesn't have any corners, symmetric. Other stuff. How do you draw a good circle if you don't have something to trace, like a can or something? What's the other way to draw a good circle? Should have brought my compass with me. Oh, compass, right? Or a piece of string. Come on, you guys did this in high school, surely, right? Geometry stuff. You never used a compass? And all right. So, hey, y'all talk about those things for a second. I'll be right back. I'm so disappointed that you've never even seen a compass before. Okay. So, you've really never seen or used a compass before?
We've seen it, we just didn't know it was called.
Okay, this is called a compass. There's a different kind that points north or some dumb thing, I don't know. How do you use one of these? Okay, one end is very sharp and pointy, and it's not a good compass unless the pointy end is very, like if you couldn't lose an eye, it's not a good compass. So you want a very pointy end here, and then the other end's got a pencil or something, right? Okay, so how do you do it? How do you do it? How do you use it? You stick the pointy end down, you try to hold it real still. And then you go like this, and what happens? Makes a circle. Why does it make a circle? Because it goes around that center point where you stuck the stabby end down, right? Sorry, the pointy end. That's the friendlier version, the PG version. You put the stabby end down, that's the center. What does this do? Like, notice I wiggle this around, it doesn't really close, right? What's that doing? It's important to actually get a circle that this distance doesn't change, right? I mean, if that changes, you don't end up with a circle, right? You end up with something else. So the two things you want your compass to do is one, have a very stabby end, because if it's not very stabby, then it's going to move around and, keep that center fixed. And be, sort of rigid enough that it's not going to like close on its own, right? Okay, if you don't have a compass and find yourself needing to draw a circle, you can use a shoelace or something too, right? You hold one end real still and use the other end, because what you need to do is keep that center point fixed and keep the distance out fixed as well, right? As best you can. What are those two things called? Well, one of the names the same we've already used, right? The center is the center, right? That's where the stabby end goes. Where the stabby end goes. If I get weird emails from my boss or something about people's parents complaining about me talking about the stabby end, whatever. I realize now that I'm recording this and whatever, it's fine. What's the radius? That's this distance right here. That's how wide the compass is, right? Distance from the center. Distance from the center to the edge or the boundaries, the cool math word, of the circle. If you know those two things, you know everything you need to know about the circle, right? The center and the radius give you a circle like uniquely, right? If the thinking about it, like in the plane, like graphing it, if the center is 1, 3 and the radius is 4, there's only one circle that looks like that, right? Okay, diameter and circumference. We're not really going to use these as much, but just for the sake of reminder, I guess, the diameter is the distance all the way across, so it's double the radius, right? So that's if I, drew my circle out and went sort of all the way through that from one edge to the other. Okay. Distance across the circle, but like through the center, right? That part's important. And the diameter is 2 times the radius. Circumference, we're not really going to do anything with it all. I just want to, remind you. And also, 3 bullet points look weird, so I needed a 4th one. How do you find the circumference if you know the radius or the diameter? Yeah, pi. Pi comes in. Pi r squared, you're thinking of the area, but it is related.
circumference is pi times the diameter, or 2 pi times the radius, because the diameter's 2r. This isn't just like, oh, weird, pi shows up. This is pi. Pi is the ratio of the circumference to the diameter. That's what pi means. That's why we care about pi. Okay, for this class though, we're not really gonna care about pi, but there it is. All right, so if we're gonna draw a circle with center 1, 3 and radius 4, what can we do? Say again. Okay, mark 1, 3. That seems like a good place to start. There's 1, 3. Now I want it to have radius 4. Now I can't use my compass on my iPad, or people will be cross with me for having broken my iPad. So how can we, get a reasonably good version of a circle? Where can I get some points that are going to land on it using that radius 4? Four to the left, 4 to the right. You can get 2 more by going 4 up and down, right? Why are those convenient directions to go? Or why can I be confident that I'm landing on the right point going those directions? The distance, yes, and this is, we're doing this on a square grid, right? Okay, well, on a square grid going in the cardinal directions, up, down, left, right, that's easy, right? I can count those. So I can count 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I can count those. I can count those, which means I can write down what their coordinates are, right? That point that's 4 to the right, what would its coordinates be? From 1, 3, go 4 to the right. 5, 3. Right? Y value doesn't change, the x value does. 4 to the left would be there, 4 up, and 4 down. And then I can draw in something that looks like a circle. Oh, wow. I like it when it does this kind of thing, because it's supposed to you draw the thing and it's like, oh, you're trying to draw a circle. Here you go, I'll help you out. But then sometimes it does stuff like this and, you feel really offended. It's like the app is like, were you trying to draw this bizarre shit? No, I wasn't, man. Obviously I'm trying to draw a circle. It's like it's, throwing a little shade at me. All right, there we go. Here's a circle. I'm cheating a little bit. You just, sort of do your best. My circles always look kind of like weird lumpy potatoes. That's fine. There's a circle. I'm not going to make you graph circles anyway. So there's a circle, right? Now, again, because we're on a square grid, those 4 points are easy to find. All of the others, and anybody that did trig in high school, you've seen this before. All of the others, the coordinates are a mess. There might occasionally be a point where the points are, kind of nice, but mostly you need trigonometry to find them, and it's kind of a whole thing. So you go on pre-cal, you'll see some of that there. We're not going to worry about it too much. But the thing we are going to worry about is hanging on to this idea that unless we're going out in the cardinal directions, because we're putting a round thing on a square grid, and those don't really jive well, right? It's, square peg, round hole kind of thing again. Because of that, we're going to have to be careful about how we handle some things. So in particular, again, so far, if we know center and radius, then we're good to go. So those are the things we're mostly going to focus on. So do this stuff. Plot these 2 points, -1, 4, and 3, -2. There's a blank graph right there. Draw a straight line between them. I would use some kind of a straight edge to, try to do it kind of reasonably precisely, and then see if you can estimate where the center of the circle is. See if you can think through actually finding it. and then finding the radius as well. So I'm gonna give you guys, 10 minutes or something to kind of work on that in groups and talk about things, and then we'll talk about it all together. All right, so we got the points, and we got a line between them. All right, those 2 points are on the outside, so they're on the circle itself. They're on the boundary of the circle itself. So what is that line that goes between them then? It's a diameter, yeah. That line is a diameter, right? Okay, so these 2 points are the endpoints of a diameter. Think about a circle with lines that go through the center sort of all the way around. Those are all diameters, right? This is one of them. So these 2 are endpoints of a diameter. We'll see that language come up again. So that straight line between them passes all the way across the circle through the widest part, like right through the middle. So if we're trying to estimate or find the center, what should we look for? The diameter goes all the way across and through the widest part, so through the middle of the circle. Where does the actual center occur? Okay, well, how about the radius thing? So radius is distance from the outside to the center, right? How does diameter compare to radius? Half, right, or double, depending on which one we're talking about. So if this is a diameter, this is a radius, and this is a radius. So where's the center? In the middle, halfway. Okay, so we need to find the thing halfway across that line. Any ideas about how we could do that? I mean, just visually, where does it look like it is? 1-1, right? I drew mine double scale just so the picture would be bigger, but that looks about right. Again, I drew mine, double scale, just so the picture be a little bigger. Center at 1-1, we think, maybe, like I plot that point, it looks about right. I don't know for sure yet, because I'm still trusting my drawing at this point, if it actually hits that grid point, or if it's like 0.95 or something, right? How can we get more detail about that? Any ideas? Anything we can track? Add it up. Add what up? From one side to the, okay. So basically just sort of, if we squish everything down to the x-axis and look at how far that is. Okay, so -1 and 3 here. Sean said add them up. That's 2, right? And then do what with it? Oh, like count? Okay. Yeah, I mean that's kind of the same thing. Counting would be 1, 2, 3, 4 from one side to the other, right? And then what? Divide by 2. Why 2? Because it's half. Yeah. Yeah, exactly. Okay, so count them up, divide by 2, that's half, right? Okay, well, if these are, further apart, I might not want to like count the whole way, but that does work. If I figure out what that total distance is and divide by 2, that'll tell us where it is. So 4 that way, half of that would be 2 and 2, right? And if you go 2 over from -1, where are you? 1. And if you go 2 over, this way from 3, you're also 1. Okay, so that sounds right for the x coordinate. Do the same thing for the y. Do you get 1? How far apart are 4 and -2? Those are 6 apart, right? Half of that would be 3. So if you go down 3, you're at 1. If you go down another 3, you're at -2, right? So we can kind of do if you wanted to, the sort of stair-steppy sort of thing that you would do in dealing with like slope, right? How far over and how far up or down. These are right angles because we're going, straight up and down and left and right on this grid. So 3 and 2, 3 and 2 there. And if you do that from 1 and then do it again and end up at the other, then the point that you pass through the middle would be the center. So this is the center at 1, 1. Another way of thinking about how we're doing all that is we're just averaging, right? We're just taking the average x coordinate, because what we did is add them and divide by 2, right? Well, that's an average. That's how you average 2 things. So finding the center, we just want to average the x and the y separately, right? So like you find the x coordinate of the center by averaging the x values. You find the y coordinate of the center by averaging the y values. That's exactly the same thing as the midpoint formula, only I'm not gonna call it the midpoint formula, because when you call it formula, everybody thinks like, oh, I gotta memorize this formula. It's not a formula, it's an average, right? Just take you know how to do an average. Add the things together, divide by 2. If you like formulas and whatever, then like do that. I'm not gonna stop you, but that's all it is. Okay, so one more time. If I wanted to think through finding that, I could get the x value by taking -1 and 3, the x coordinates, add them up and divide by 2. That gives you 1. And the y by doing the same thing, 4 plus -2, which also gives me 1. So the center is 1, 1. And again, all I'm doing is averaging, right? So add, divide by 2, because there are 2 of them. Everybody cool with that? Okay, great. All right. The other thing that we need is the radius. Any ideas? Where would the radius be on my picture here? It's the distance of the length from the center to the outside of the circle. And these points are on the outside, right? So I haven't drawn it because the picture's cluttered enough, but the circle will be right out here. So the radius is this distance and it's this distance, right? Either of those would work. Okay, how can we find it? Any ideas? Do it. Well, we can't do exactly the same thing because we did exactly the same thing. We get back what we just got, right? We can use a pretty closely related idea. We can use the stuff we've done so far. Oh, what about it? Yeah. What's there? This thing all in orange up here in the upper left. What is that? It's a triangle. What kind of triangle? A right triangle. Because 2 of those sides we went straight up and straight down and straight left and right. So these meet at a right angle. That means this and this, which I can count, right? That's easy. The whole thing was that we're on a square grid, so it's easy to count up and down or left and right. It's not easy to count on the diagonal. This I know is 3, this I know is 2. I want the third side. What's just the hypotenuse of a right triangle? All right, so Pythagorean theorem. Let's get rid of this stuff. Finding the radius. We're going to use Pythagorean theorem, which says the square of the hypotenuse is equal to the sum of the squares of the other sides. So C here, that's the longest side, that's the hypotenuse, that's the radius that we're looking for, right? A and B are the 2 legs. So 3 squared plus 2 squared equals, again, that's our radius, so I'm going to label it as R. 9 plus 4 is R squared, so R is the square root of 13. Square root of 13 is 3 point something. Hopefully you can kind of imagine how, if this is 3, then that's got to be a little bit longer, right? Kind of sort of see visually how that would work. Okay, so again, all I did is use the things that are easy to do on a square grid, right? The thing it's good at is moving up and down, moving left and right. Okay, well, I need to get from here to there.
I can count how far down, I can count how far over, right? That's just counting the distance the same way you would slope, right, and run kind of thing. So down 3/2, okay, well, the thing that I'm actually interested in then becomes the hypotenuse of this triangle. Well, thankfully, I know how those things are related, so we can find it. This is also the same thing as a thing called the distance formula that looks big and scary and messy. It's just a Pythagorean theorem where you solve for C. So I'm gonna write it down. I don't think it's in your best interest to try to use it, but again, you do you. That's the distance formula. Like any other formula, if you goof some part of it up, it doesn't mean anything, but this is just what we just did. This is how far over, this is how far down. You square them because they're the legs, you add them together because Pythagoras says to, you take the square root because you're solving for the C thing. If you want to use that, if you're into the formula thing, then like go for it. I'm not gonna stop you. But again, if anything in there is not in the right place or whatever, then it doesn't mean anything. I think just keeping track of Pythagorean theorem that you've known since you were 12 or something is the better way to go. But you do you. Okay, everybody good? Okay, so two things we need to be able to find: the center and the radius. We can get the center by taking an average. And we can find the radius by drawing a triangle. And use the Pythagorean theorem, right? Which I understand, like that's a formula too, but that's one that's just like sort of part of the culture, right? Anytime there's some dumb math thing, somebody writes the Pythagorean theorem down in the background, right? So yeah, that's the idea. That's what we need to be able to do. Okay. So if we have those, we can write down the equation of a circle. The equation of a circle basically just says, again, going back to my compass, it's all of the points that are some set distance from a center, right? So I point the stabby end down to mark the center. I keep the distance fixed. I trace out all the points around the circle, right? Well, if the radius, the distance is tied to this idea of Pythagorean theorem and stuff, then the equation for a circle, the equation that tells me how all those XY pairs relate, should look a lot like the Pythagorean theorem. And look at that equation at the top of the back there. This is the kind of standard form version of the equation for a circle. What does that look like? A squared plus B squared equals C squared. Because it is, right? The radius is the distance from the center. The X and Y, that's telling you about the coordinates. What do you think H and K are? Look at where they are. Look at how this thing works. Think about stuff we already know. X minus H squared. So you've got this thing that you're adding or subtracting kind of grouped in with the X value inside what happens to the X value, right? What does that do in terms of moving or translating a graph? Shifts it to the left and right. If it's -1 or something, that's to the right. If it's +2, that's to the left. Okay, so this is just a left-right shift thing. What's the one that's grouped in with K then? Or with Y? Sorry, that's up and down. Now, the one place that this is a little bit weird or different than what we've looked at before, it's not really different, but it looks different. We're used to seeing things where I've got things written out as Y equals whatever, right? So there, if we have something that's shifting up and down, it's like a +1 out at the end. Well, what we're looking at here is that the Y is on the same side of the equation as X, right? So it's like everything's been moved over. So that up and down shift kind of feels like it works a little bit backwards. So for example,
x minus 1 squared plus y plus 2 squared equals 4. This would be a circle where the center is -1 here, so it's like a shift to the right by 1. So the x coordinate is 1. This is +2. If you look here, this is minus k, right? So think of this as like minus -2. Or think of that +2 as shifting everything down because it's on the opposite side of the equation from where we usually see it. So the y coordinate there is -2. If you want another way to think about that, the center should be the thing that makes both of these zeros, right? That sort of, if you like plug both of those coordinates in here at the same time, it would zero out. 1 minus 1 is 0, -2 plus 2 is 0. That's another way you can kind of think about what's going on there. And that works because the circle doesn't actually go through its center, right? The center's in the middle of it. So the center is 1, -2, and then the other side, the 4, that's the square of the radius. So the radius here is 2. All right, so what's the equation of that circle that we just looked at here? Its center is 1, 1. So the, like a squared part, if you want, should be x minus 1 or plus 1? -1, yeah. Shifting 1 to the right. And then here, this would be y, also -1. Again, then 1, 1 with 0, both of those out. And then the right-hand side is the radius squared. Square root of 13 squared is 13. Again, you can think about that just like Pythagorean theorem, a squared, b squared, those are the vertical and horizontal legs. And then on the other side, the hypotenuse, that's the radius. Okay, so what are the center and radius of this circle? Again, start kind of, sort of by default, I guess, at the origin, right? This +4 would shift everything to the left by 4. So the x coordinate should be -4 then. And 0. Okay. -4, 0. What about the radius? Square root of 20. Is 20 a perfect square? No. Can we break it down? Yeah. If you remember how to do that. 20 is not a perfect square, but what are some things that go into 20? 4 and 5. 5 is prime. It doesn't break down anymore. And 4 is a perfect square, right? So the square root of 20 is the same thing as the square root of 4 times 5. And the square root of 4 is 2. So the square root of 20 is the same thing as 2 square roots of 5. So we can simplify that down a little bit further, even though 20 is not a perfect square. The idea is just you do sort of a like prime factorization, or you factor it until you can spot perfect squares in there. And then if it's a perfect square, you're doing a square root, so you can actually do that. Makes sense? Everybody okay with that? All right, so look at the other stuff there, the other problems here. The first three are pretty much just write down the equation, or given an equation, write down the center of the radius. 4, 5, and 6, you're actually finding stuff, so you need to find the center and the radius. Give those a shot tonight, and we'll spend a little bit of time tomorrow, maybe working through one more example if we need to, and then talk about whatever else we need to get ready for the test. So go over stuff, study like the test was tomorrow. Keep track of things you want to talk about, and we'll talk about them tomorrow. All right, y'all have a good day. I'll see you tomorrow.